Welcome to E-Padasala PG program for computer science students. So, in this lecture we will be covering about serial port programming in assembly language. So, in this course we will be discussing about serial communication, how it has been controlled by the different control register, and the different baud rates, how we will be setting up different baud rates with microcontroller, and we will be writing assembly program for serial port communication. So, in this actually first we will start with what is the baud rate and how it is very important. So, when you are looking at 8051, it will be connected with some output device or some input devices. So, those devices which will either send, I mean if it is connected to an output device and the output device will accept data in serial communication only, then the serial transmission is given to that particular output device. So, if this is the case, we need to know what is the speed of the output device with which it will be in a position to receive the data. Then the 8051 will transmit data in that particular speed only. So, that only the output device will be able to catch up all the data which is transmitted by 8051. If I am reading something from an input device and the input device gives the data to 8051 in a serial mode, then we need to know what is the speed with which it will be sending the data to 8051. Then the 8051 is configured with the speed to receive the data in that particular speed. So, that particular speed I can call it as bits per second, which is nothing but baud rate. Now, with this particular baud rate we need to configure, that is very important. If I am connecting 8051 with the PC's COM port or any system, then there should be a match between these two things. 8051 will be in a position to configure to different baud rates. So, this baud rate configuration is supported by the timer of 8051. So, usually we will be looking at the baud rates of 110 or 150 bits per second or 300 bits per second or 600 bits per second. But very famous things are this 1200 bits per second, 2400 bits per second, 4800 bits per second and 9600 bits per second. So, 19200 bits per second is also possible. So, these are the baud rates. This will be, I mean the system will be supported, usually the IBM will support this kind of baud rates. So, now when you are looking at your 8051, we will be in a position to look at how we will be configuring this particular baud rate, that is very important. So, we know very well we have a different clocks, I mean oscillators inside it, CPU oscillators inside it, CPU clock cycles generated is different. So, we have 11.0592 megahertz is one particular crystal oscillator which generates the thing, and maybe 12 megahertz oscillator is there, 16 megahertz oscillator is there, we can use 20 megahertz oscillator is also over there. For our example, we will take 11.0592 megahertz oscillator which is generating the CPU cycles in 8051. If this is a case, as we discussed in the earlier lectures, the machine cycle frequency is actually 9921.6 kilohertz. That means 12 cycles, I mean when you wanted to have one machine cycle, then we need 12 clock cycles. So, based on that only we will be doing all the work. So, the 11.0592 megahertz divided by 12 will give you the machine cycle frequency, which is nothing but 921.6 kilohertz. And the UART, see when you are looking at, normally it will be of this, but when I am looking at serial communication where the UART supports, which is inbuilt device which is available in 8051, which divides again the machine cycle frequency by 32. So, once in, I mean if I am having something 921.6 kilohertz divided by 32 will be the clock cycles, it will be support, the UART supports for data transfer. So, now when I am dividing this one, I will be getting only 28,800 hertz, that means 28,800 clocks per second. So, we can send at the maximum of 28,800 bits per second. So, but we will be requiring only either 12,000 or 2004, 1200 bits per second, or 2400 or 9600, that kind of baud rate only we need it. So for that particular reason, we need to reduce the speed of this particular process. So for that particular reason, we will be configuring using timer 1 in program mode, and mode 2 in the sense 8-bit auto reload mode. So now we will know how we will be configuring this particular baud rate. So you just see that we will be having 11.0592 divided by 12 is 921.6 kilohertz, and it is divided by 32 for UART. You just see that it is divided by UART. So I will be getting only 28,800 hertz, but we need only either 9,600 or 2,400 or 1,200. So what we are trying to take over here is, if I am dividing 28,800 by 3, which comes around 9,600. So in 3 clock cycles, if I am sending 1 bit, then I will have 9,600 bits per second can be achieved. So once in 3 clock cycles, I can send only 1 bit. So that is the way I am configuring the speed. So now if I am dividing this number by 12, I will be getting 2,400. If I am dividing it by 24, then I will be getting 1,200. So 24 clock cycles, if I am sending 1 bit, then I will achieve 1,200 bits per second can be sent or received. So this has been configured with the help of the timer 1, in which the TH1 is loaded with -3. That means when 3, if it is -3, then if 3 clock cycle it counts, after that it gets a overflow. When the overflow comes, which in turn allows the data to send 1 bit. So that is the way the baud rate is set with the help of the timer, so that the speed is also maintained. So you just see that this is actually 9,600 baud rate, TH1 is set with -3, and if I am putting it in a hexadecimal value, it is FD. That means F of -3 is nothing but FD. So for 4,800, I have to set -6, and this is F of -6 is nothing but FA. So 2,400 minus 13, 1,200 is -24. Either I will set minus this values, or I will set this hexadecimal values in the timers TH. Timer 1, the TH value, where you have to set this particular values. And with your SBUF register, usually for the serial communication, the first thing is the whatever be the baud rate, we will be setting it. The second thing is how we will be sending the data. So as I told you, if I wanted to send the data will be in a word format. If it is in a word, in the sense it is of a 8-bit. So if it is 8-bit, this has to be converted into bit after bit. That means it has to be serialized. So that has been done at there should be an interface buffer which will be used for this particular purpose while sending it outside or receiving it from outside. So by the time we will be using this SBUF register, which is otherwise called a serial buffer. So how we will be sending the data is nothing but move SBUF #D. That means hash indicates immediate, D is the data. I am moving the D to SBUF. Now from there onwards, I can send the data to transmission. I can send the data outside. If I wanted to receive a data, I will receive the data in A. I will receive whatever be the thing which is available from outside to a serial buffer. Now in the serial buffer, everything is combined together to make it as a word. Now that particular word is send it to my A, which is happened through move A, SBUF. So the serial buffer is acting as a interface between the processor and the outside world to convert serial data into parallel data or parallel data to serial data. So now TXD and RXD is directly connected to SBUF. So this is the way we will be handling the situation. Now the next important thing is your SCON register, which is nothing but control register for serial communication. In 8051, this is the format of SCON register which is used for serial communication. There I will have SM0, SM1 and SM2, and REN, TB8, RB8, RI and TI. Here these two things are very important to set what is the mode, and this REN is very important to set whether we will be receiving, I mean we will be enabling the data reception, or I mean we will be if I am setting one, that then it is enabled for reception of serial data, and TI and RI are the bits which will be set by the hardware. When we are receiving a data, this will be set by transmit input, interrupt flag. When you are transmitting, it will be the whole thing is finished by indicating the hardware by setting up this TI bit, and if I am receiving a data from outside, then this hardware sets RI while it completes receiving the whole data. So these two things are needed to identify whether we have received fully or we have transferred fully the serial data, and these two SM0 and SM1 is used for setting up what is the serial communication mode we will be using it. Usually we will be setting SM0, SM1 as one first mode, so that which will support the UART kind of communication, and the REN is set so that this supports the communication, serial communication, and these two things are set by hardware, and it has to be cleared by the software to run the things properly. So it is actually a SCON, serial control register. So when you are sending a data, this will be sent with the start and stop bit. We should remove start and stop bit before processing the data. That is also we have to consider. Now when you are looking at serial communication, I have SM0, SM1. Mode 1 is always preferred, where this mode will have one stop bit, one start bit, and 8-bit data is there. So totally 10 number of bits is there, one start bit and all 8 bits, one stop bit. So this will be compatible with COM port of PCs, and this has been supported by UART of 8051, and we have to set REN, receive enable, and this if it is 0, we can't receive serial communication data. So this TBRB will not be used much. So TI transmit interrupt is set by the hardware, RI receive interrupt is also set by the hardware while we received the data completely from outside. So these two are very important. Why? Because when I wanted to transmit the data, we need to know that whether the data is transferred completely or not. So that after completing it only, we have to send the next bit, next byte, next word. We should not overwrite on the same data. Because of that, we will be using this particular one. While you are receiving also, if you have received completely to SBUF, then this will set the RI flag. Then we can read the whole thing. We will not, if in between if you are reading it, we will read only the partial data. So for that purpose, to make the data transfer properly as well as to read the data properly, these two bits are set by the system. To send the data serially, we will be using this particular steps. So the first thing is when you wanted to send the data, we will be first we have to make the baud rate has to be set by making what is the value has to be loaded with its TH, and the timer is set to mode 2. Then the SCON register is loaded with the value of 50H. 50H in the sense we will be setting REN as well as serial communication mode 1. Serial communication mode 1 and REN is 1, which enables the things, and all other things are not set. So 50 is moved to SCON to ensure that the serial communication can be invoked, and TR1 is set to 1 to start the timer. So which makes the baud rate has to be maintained properly. So while you wanted to communicate or you wanted to receive, so by the time we have to start this particular timer. Then the TI, first the TI should be cleared, because if accidentally it has been set, it has to be cleared first. Then the character byte to be transferred serially is returned to SBUF register. We have to write whatever be the data we wanted to send serially has to be sent to your SBUF register. So after that we have to wait for TI flag to be set by the system. That means that serial communication is sending outside. That means the transmitter sending the data from the SBUF. Once it is completely transferred, then the system sets this particular TI flag. So this has to be monitored continuously till you will be in a position to get TI as equal to 1. So this has been done continuously. That means we will be going to step 5 again and again. Once it has been transferred completely, then you have to clear this TI flag, send the next character to SBUF, then you wait for TI to be set. Once it is there, you clear it, again send the data to SBUF, wait for TI flag. So this is the way the serial communication has been done with this loop. So now you see the exact assembly program which will demonstrate how a data which is nothing but a letter D has been sent continuously through serial way of communication with 9600 baud rate continuously. So first I have to set move T mod #20. So this says that timer 1 mode 2 is set. Mode 2 is nothing but auto reload. No need to again reload this the TH as the value as -3. Once we have set -3, this will be again and again reloaded once we will be getting a overflow. So move TH1 -3, which enables 9600 baud rate. That means with the 3 cycles I will send 1 time 1 bit. Move SCON 50H #50H, which invokes the serial control register to permit serial communication. Okay, once this says that 8-bit data is sent, 1 stop bit, and REN is also enabled to receive the data. The serial communication is enabled. Now set B TR1. Now we have started. All the platform is set. Now we have made set B TR1. TR1 is equal to 1 in the sense timer 1 is getting started. So now move SBUF #D. So now the D is moved to your SBUF. The data is available in your SBUF. Now it has been transmitted outside. We will be watching whether will be received TI is equal to 1. So here it has been put it in a indefinite loop, JNB TI here. That means if the TI is not equal to 1, then come to here. So it gets again and again indefinite loop. Once when I am getting TI is equal to 1, it comes out from here. So now it says that the data has been sent properly. Now the clear TI, because we need to send the next character, then jump again. Here we are sending D continuously. So because of that we have come over here again we will be sending D to SBUF. We will be watching TI is equal to 1 or not. If it is 1, we clear, again going over there. So this is the way, this is the assembly language program which helps us to communicate serially the letter D through your 8051 controller with the baud rate of 9800. So here the importance of TI flag is that if it has not been raised, then we will not be knowing that when the transfer of data is complete. So and once it has been set, it has to be cleared, because it has been set by the hardware. So we have gone through that, it has been sent properly. So because of that we have to again clear it, so that we will enable for the next transmission. So for that, for the smooth conduct of transmission, people are looking at this TI flag. So the next task is we need to send the data serially. So for that particular reason, this is the steps we have to follow for sending the data serially. So here you just see that we have loaded this baud rate by making TH should be loaded with that particular value, and the timer 1 is set with mode 2, and TH is loaded with the proper value for baud rate. SCON register is loaded with the value of 50, which indicates that the serial mode communication 1 is there. It always will be preferring mode 1, and 8-bit data is framed with the start and stop bits, that has been indicated over there. For that only we will be using 50, and TR1 is timer is set to 1 to start the timer. TR1 is equal to 1 to start the timer, and RI is cleared, because before starting the communication we will clear the RI flag. After that the RI is continuously monitored. now the serial communication is started. Now we need to monitor the RI flag, which in turn says that if it is equal to 1, then it says that SBUF is received the whole data. Once it is RI, so till then we have to be in a indefinite loop over there. RI is equal to 1, then SBUF has a byte, and these contents are moved to whatever be the place, destination place we need, where you can move this SBUF value to that particular place. And this, if I wanted to receive the next character, then I have to go for step 5, and I have to repeat again and again. We have to clear it, we have to monitor it. If RI is equal to 1, SBUF have the data. From the SBUF we have to send it to send the data to a safe place. So that is the way, again and again we have to receive the data. It has to be come to SBUF. From there you have to send a safe place. This is the way the data is received serially in the 8051 controller. Now we will see that there is a example assembly program which has been written to see how it has been happened. So here this is actually a data serially received, and parallelly we will put that particular received data is in P2 port 2, and the baud rate with which we will be receiving is 9600, and it is a 8-bit data and 1 stop bit. So if this is the case, I will be setting up timer 1 move tmod hash 20, which tells that timer mode, timer 1, mode 2. Now th is equal to th1 is moved with move th1 comma hash -3, which tells 9600 baud rate. Move SCON hash 50, which is nothing but which sets the serial communication controller register to enable the serial communication. Now set B TR1. Now we have started the timer so that the serial communication starts. Here JNB RI here, that means we will be looking at the RI value till we will be getting a 1, it gets looped over here. Jump if no bit of RI, then you will be looping over here to here. So once when I am getting RI is equal to 1, I will come down. It fails and will come down. There move A comma SBUF. Whatever be the content of SBUF is moved to accumulator. Move P2 comma A. Now the accumulator content is placed at P2 because our program says that read the data serially and put them in P2. Now I will be placing the data in P2. So after reading the data, I will clear this particular RI flag. Otherwise we will think that the data has reached the next data, we will be ready for receiving the next data. Then S jump here. So now we will be waiting for the next data to be received. Once it is received, then put it in TPP2 and clear it, again go over there. So this is the way we will be doing the work, so that we will be receiving the data continuously serially from outside. So when you are looking at the RI flag, without RI flag we will not be knowing that whether we have received the data completely from outside. So now remember that the baud rate when you are looking at, we will be looking at certain baud rates. Sometimes we need more than that speed also we may need it. For that particular reason they have provided one particular register which is called a PCON register. This is actually a structure of PCON register where if I am setting this SMOD bit as 1, then this is whatever be the baud rate we will be using, it is doubled in the previous case. So if SMOD is 0, I will be having the baud rate as 1 by 64 oscillator frequency. If SMOD is equal to 1, the baud rate is 1 by 32 oscillator frequency, which means you just see that when I am looking at external oscillator, divide by 12 is 1 machine cycle frequency, divide by 32, which gives you 28,800 hertz, 800 clocks per second. This is what we will be always using it. If I need more, then I will set as SMOD as 1, which in turn makes this frequency as 57,600. So if this is the case, if I am setting it SMOD as 1, if I am making it TH1 becomes -3, which in turn makes instead of making 9,600, 19,200 baud rate is maintained. If I am putting it -24, which makes with SMOD as 1, 2,400. That means double the baud rate can be made if I am putting it SMOD equal to 1, which has been achieved, which can be achieved by setting up in the PCON register SMOD is equal to 1. So when you are looking at the data, whatever be the data we wanted to send or receive, we know very well that sometimes we may need to read as well as send data serially. So, one of the example programs which follows, which gives you a clear indication about how to receive, how to send data serially in a parallel way. Okay. So, this is the problem where in the 8050 serial port, which is connected to a COM port of IBM PC, and we are using a terminal program to receive data, to send and receive data serially, where P1 and P2, port 1 and P2 of the 8051 are connected to LEDs and switches. You just see that it has been connected. P1 is connected to LED and P2 is connected to switches, and when you are looking at what is the task we need to do, it is we have to write a code in 80 program assembly to send the PC the message we are ready. So, some message we are some message has to be sent to your PC serially, and receive any data sent by the PC and put it into the LEDs connected to the port 1, and get the data on the switches connected to P2, send it to the PC serially. The program should perform only one time whatever be the data we wanted to send it from I mean the PC has to be sent. Okay, that has been done only one time, and this LEDs and your switches, the communication has been done continuously, and all these programs has to be done with 4800 baud rate. This is what we have demonstrated with this particular program. Here I made it org is equal to 0. Now we started with the starting position as memory position as 0. Now P2 is set as 0 FF, which means we will make the port 2 as an input port, and T mod is set as timer 1 2 0, which makes timer 1 mode 2. TH1 is set to 4800 baud rate by moving 0 FA. TH1 is moved with FA hexadecimal value, which in turn makes the baud rate as 4800, and SCON is set with 50, which makes 8-bit one stop bit, and it is enabled for serial communication. So we will be starting the timer by making setB TR1, and now move the data. Now I wanted to move whatever be the address where I have written the data. So that particular address is moved to my DPTR. So DPTR, the pointer from the external memory to point whatever be the address we wanted to point to the external memory will be available in your DPTR. Now this is a program segment where first I will be clearing my accumulator. After that, whatever be the it is now 0 plus whatever be the content of your DPTR, that means the address, external memory address at. So now I will be reading the data from that particular position. It has been moved to A. Now first letter is read from there and it has been moved to A. Now this is for checking up if we have received the last letter. We made it something like the last letter will be 0. So based on that only the last letter may be 0, means we can stop reading the data. So that way we have controlled. So jump on 0 B minus 1. If it is 0, it comes down, otherwise it will go. So A call send, this subroutine we call to send the data. Increment DPTR. Now I will be reading next address is taken, and sjump H1, it comes over here. From there, from that particular next location I have read, I am sending it. Next it is getting incremented, again I am sending it. So that way serially I am sending it. Once I received a 0, I will be coming out. So this has been done only once. Now when you are looking at here, I have read the data P2, move A comma P2. P2 content is moved to A. Now I am sending it again, using a call send. Send is a serial communication transmission routine. A call receive. Now receive whatever be the data I am getting it from outside in the serial data buffer. Then send that particular after receiving it I need to send it that maybe it is in A. Now I am sending it to P1 and sjump B1. This has been done continuously. Read from P2, send it serially, receive something from outside, send it to P1. So this is what happening again and again. Now we see how it has been sent. Send is a serial communication subroutine. So now you just see that move SBUF comma A. Whatever be the content of your A is moved to your SBUF. Now I am monitoring my JNB TI. So I will be looking at whether the TI is equal to 1 or not. Till then I will be looking at again and again. So once it is getting a 1, then I will clear it and I will return to the caller. That means whatever be the data I wanted to send it, I will send it from the SBUF. A to SBUF I have placed. Now I am monitoring TI, it has been sent. While I am receiving it, it is very simple, JNB receive RI, again I am coming over here. Till I will be getting RI flag is 1, I will be waiting. Once I am getting it, I have read that particular thing, I have put it in A, move A comma SBUF makes SBUF whatever be the data in SBUF is moved to your A. Now you will be clearing it, returning it. So this subroutine is returned to the main program. So this is the way the sending and receiving is written separately. Wherever in your program you can call these routines to enhance or to support serial communication in either transmission side or in a receiving side. So the data we have written over here is we are ready, and there is it has been ended with 0. So we have read one after other by looking at what is the address. We have read it from outside, one character and the next character in the different addresses, consecutive addresses. Once we have received 0, we stopped sending this particular one. So this is the way the 8051 controller is programmed to read and to receive, to send, to read the data from here, to send the data from here to this COM port, as well as read the data from this particular port switches and send it to LED. So whatever be the transmission or reception done through your serial communication can be handled through these two this send and receive subroutines. So any kind of transmissions can be achieved through this kind of transmissions. So when you are looking at this kind of 8051 serial port programming, we will be always looking at your TI is there, RI is there. Some time is wasted looking at all those things. This can be avoided by making it using a interrupt based serial communication transfers, and sometimes will not be in the new generation 8051 microcontrollers come with 2 serial ports. Now we will have only one set of RX and TX port. Now in the next generation we will be having another one set of serial ports. So with 2 set of serial ports as well as using interrupt based data transfer, still the serial communication will be improved much better in 8051. So in this lecture we have covered how to configure the essential register for serial port programming, that means configuring the SCON register, and how we will be calculating the values to be placed in the timer for setting up a different baud rate. And we have finally we have gone through how to read data serially in 8051 using a assembly code, how to write data, how to send data serially, how to receive data serially. Both the things we have gone through, either from a PC or to a PC or to a serial port or to a LED devices or different ports. All these interfaces can be done. For serial communication, we have gone through sample assembly codes for transmission as well as reception. Thank you.